Okay, wide area networks, and one of the real focuses of wide area networks is going to be frame relay. What's the difference between a WAN and a LAN? Yes.
Wide area network is a network that is outside of your direct network.
It is. Okay, what else?
How you get your internet and also
How you get your internet, so what's the real difference? Wide area networks. Oh, it's big, right? Local area network is little. Is that necessarily true?
local area network can be just as big.
Local area network, so what's the difference between a LAN and a WAN? What are the real differences between a LAN and a WAN? The distance that they cover. Heck, man, I can set a WAN up right back here on these routers that are laying next to each other, and they're only 6 inches apart. The amount of equipment that you need? Trick question, isn't it? I want to go back to the OSI model. What's the difference between a local area network IP address and a wide area network IP address? Well, go get your notes. Tell me what the differences are between them. What kind of IPv4 we're talking about now, but what's the difference between them? What's the difference between them?
I would say the easiest way to say it is for a local area network, we can all be hooked up to one switch.
We can all be hooked up to one switch. No, that's true.
We need to go outside
That's true.
local switch.
That's true, but that's a subnet. If we need to go outside that switch, we could do that with VLANs, couldn't we? Outside of our current router. You like the way I'm making you think, maybe think? What are the real differences? Are there differences between a local area network IP address and a wide area network IP address?
I'm thinking all depends if it's connected to the internet or not.
All depends on whether you connect the internet or not, but does that make a difference in the IP address? That makes a difference whether it's routable or not, and you're talking private IP addresses are not routable. Okay, big deal. Can we put a public IP address on all these computers in this room? Would they work? I think so. So what's the difference in the IP addresses? Thank you, finally. There aren't any. So where do the differences have to be? If we're at layer 3 and there aren't any differences there, where would the differences between the LAN and the WAN be? Transport. No, let's go the other way. Data link and physical. So where are the differences between LANs and WANs? And there are things that you said, yeah, you can go longer distances and all that because we have limited, in Ethernet, we have limited distance that we can go. Wide area network we can go long distances with, usually lower speed. And I think what you're going to find when we talk about distances that the longer the distance, the further you go, the farther you go, the slower the speed. Because in here, this machine up here that I'm using, although it doesn't seem like it most of the time, is hooked up to a gigabit port. It's got a gigabit NIC in it. 1,000 megabits per second. How fast do you go when you get to the internet? Really good internet speed. Cable modem. How fast does it go? Not fast enough. As fast as you pay for. It's up to a limit though, isn't it? I think mine is like 5 megabits. 5 megabits? 5 versus 1,000. How far am I going? Yeah, those change because you can get into sonnets, and depending on what you buy, the sonnet networks are like 48 gigabits per second wide area network. So there are faster ones, but boy, are they expensive. It's 1.5 gigabits. You got DSL, or you got cable or DSL? Cable now. Yeah. DSL tends to be a little bit slow, a little bit slower than cable. Well, one of the things, if you'll think about these, and I think they talk about them a little bit in this chapter, DSL gives you a direct connection to a switch called a central office. Well, it's not really a central office. It's a switch, a particular switch type in the phone system. Cable is, for imagination purposes, like a big Ethernet, a true Ethernet, a shared media based on your neighborhood. And if you look at the Cox cable IP addresses, mine at least is a 255.255.252 subnet mask. And if you do that, and do to the 2 to the ends, based on the host's addresses, how many hosts could be on that network? 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024, is that, am I right there? 252, 255, 255, 255, 255, 252 is 28, right? Yeah, no, it's not. It's 24, 22. Well, anyhow, it leaves me 10 bits for host addresses. Is that true? So I could be sharing that link with 1,024 other host addresses, 1,022 other host addresses. You're not going to get that with DSL. DSL is going to go direct. Now, it gets mixed in somewhere. It's a matter of where, and the point there is there's a choke point at some place. So you share the media. The fewer people that are on your cable segment, the higher the bandwidth you're going to get, because you have to share that bandwidth with all those other people. If they all get online at the same time, then you're going to slow down. You're not going to get as much bandwidth. That's why it's slowing down. Just go tell all those people get off. Yeah. Tell all your neighbors that they're not allowed to use the internet while you are. That's right. Huh? Main Street, if you got a lot, and can you imagine what it'd be if you're on a main street with a lot of apartment buildings?
Oh, I have.
And it's slow. How many are on it? What if you're in a brand new neighborhood, or what if you're in a neighborhood you got a lot of old people, like me, that don't use it that much? That's where you want to go, where all the old folks are, right? Or someplace secluded that doesn't have a lot of connection. A new neighborhood, something like that. So the difference is, so where are the differences between LANs and WANs? Let's go back to the original question. What's the difference between a LAN and a WAN? Very little. Let's use the magic word protocol. And let's talk layer 1 and layer 2. Layer 1 has the differences. Layer 2 protocols is what we're really talking about. And when we get into these things, into the Cisco world, the wide area network protocols, and he starts out by saying, well, the only ones we really talk about are HDLC and PPP, and then we'll do frame relay. Frame relay is a wide area network protocol, it's a WAN protocol. It's an encapsulation protocol, encapsulates the stuff at layer 2. Can be some layer 1 stuff, and I say that we'll talk about this much about X.25. X.25 is an old protocol that did have a layer 3 component in it. X.25 became frame relay kind of deal. Okay, so the topics covered: introduction to WANs, we've already done that. HDLC, high-level data link control protocol. PPP, point-to-point protocol, frame relay, and we'll talk just a few seconds about VPNs just so you know what they are. VPNs, we'll do configurations. In the Windows class, we do a VPN configuration. In the routers class, we do a VPN configuration. All the VPN is we talk about this trunk, this port, this pipe, and we always draw this really cool picture that shows a pipe, a dedicated link. It's encrypted data that you send from your location, your router, your endpoint to another endpoint, and then the encryption gets taken off. A couple different ways to do it, but just to know what they are. Frame relay, we'll spend some time on it. After we get done, we'll take a break, and then I want to go through 2 configurations. It's going to be 2 different ways we can do it. It's called a multi-point, which essentially is like a local area network, an Ethernet, and a point-to-point configuration. The only real difference between the 2, the commands to configure them are a little different, but one of them, all of the routers are on the same subnet, and the other one, they're on different subnets. can cause some issues, and we'll talk about the issues that it can cause when we go through these things. So WAN terms, customer premises equipment, means if it breaks, you pay for it. The DMARC is the dividing line between the ISP's equipment and the customer premises equipment. If it breaks on our side of the CPE, the customer premises equipment, or our side of the DMARC, we fix it. If it breaks on the other side, they fix it once you convince them that it's their problem and not yours. When you call these guys, it's always your problem, isn't it? Have you ever noticed that?
Yeah.
It's always something that you did or your whatever is broken. Not a whole lot of difference here. Say again?
What if it fries and it's no one's fault but the company?
What if it fries and it's on your side?
Oh, it's your fault. No, yeah, I would try to blame you first.
What if what fries? Depends on where it is. Who's going to fix it? Depends on where it is. Which side of the DMARC is it on? Yes, they're always going to try to blame you, but if it's their equipment that's fried, their equipment's fried. If your equipment's fried, your equipment's fried.
What if they give you a faulty modem?
A faulty modem.
Yeah.
They provide those. You're relating this to DSL and cable modem, and we're beyond that. We're into connecting our Cisco router into a frame cloud or into a dedicated line or whatever else.
What if they gave you a faulty router?
They don't give you a faulty router because that's on your side of the DMARC. You buy the router. And if Cisco gives you a faulty router, and as long as you have a maintenance plan, you call them up, it'll be there by 10 o'clock the next morning, a new one.
Hopefully.
There's no hopefully. Been there, done that. We had a router fail 2 o'clock in the afternoon. 10 o'clock the next morning, there was a new router right out there as soon as FedEx could get here. But only if you have the maintenance plan. If you don't have the maintenance plan, go buy your own. If you don't have the maintenance plan, you don't get updates either. So those things. The local loop is the one that comes from the distribution point to your location. Central office, again, is a switch, and the central office, the local loop goes from the central office switch to your DMARC. And then the toll network is the ISP, the phone system where you would pay long distance calls, or dedicated line, one of those kinds of things. These are just kind of what we can have. Dedicated line is synchronous serial. We can buy dedicated lines, T1 lines, the popular thing that everybody loves to have. Not really necessarily anymore. Frame relay is kind of taken over that, and frame relay will get to that. You buy a certain base level of data, and it's kind of like cable. You buy a certain base, and if nobody else is using it, guess what? You get it. Same thing with frame relay. That's one of the reasons it's so popular. So a dedicated synchronous and asynchronous serial is a circuit switch with the telephone company, and here a synchronous serial packet switched network, frame relay sort of relation. Frame relay is a packet switch network. It really uses ATM, asynchronous transfer mode, not the place where you get money, asynchronous transfer mode on the inside. So the different ways we can do this. This came obviously from a different presentation. Some of the physical connections that we can have, and we have some of those back here. When we do these things, we can have a CSU, DSU that is installed in the router itself. And we've got one, I think one of those back there, actually one of those back there does have a CSU, DSU module. What we had before that was this device down here, which was an external CSU, DSU. We've talked about DTE and DCE cables. Typically what you're going to have, the DCE is going to be at the ISP. The DTE is going to be your router. so you don't have to worry about the clock rate. The reason we have those is when we connect the routers together from one to the other directly on the serial ports. One of them has to have a DTE, one has to be a DTE, and one has to be a DCE. So each of these modules are available, and then once you get there, and if you look at that CSU DSU unit, it connects to a wall switch using an RJ45 connection. Where we're after the little break, the equipment that can be used, and a number of these are just modules that plug into the router itself. Depending on how old the equipment is, you may see something that looks like that. In the back of the room there's some CSU, DSU cable, or CSU, DTE, DCE cables. They're marked. There is one back here that's one end says DTE, the other end says DCE. It is designed to connect two serial ports together on a router. One of them has to be the DTE, one of them has to be the DCE. It has to have a clock rate. The DCE has the clock. And when you're using Packet Tracer, you connect the one with the little clock to the one that's going to be the DCE. It doesn't matter which one is, as long as one of them is a DCE. You just gotta have one. And this is another one, DTEs to DCEs, and what this is showing is our network, our side of the network is the DTE. Connects CSU, DSU, and shows the cloud. The DCEs are at the other end of the CSU, DSU. So they're going to come in to the DMARC, and you're going to connect your equipment at the DMARC. They, the ISP, are typically going to be the cloud, the DCE network. If you have more than one router inside your network, you're probably going to want to use Ethernet, fast Ethernet ports for the speed instead of serial ports anyway. So typically, even if you have multiple routers inside, you're still going to be a DTE or a channel. The Ethernet's a channel called a channel. The DTE DCE applies only to serial connection to RS-232 standard when we do these things. DCE network is not always present because it depends on how we connect it together. WAN support, and these are terms: frame relay, ISDN, LEPB, LEPD, HDLC, PPP, and ATM. What we're really going to talk about mostly is HDLC and PPP and frame relay. ISDN, the LAPB, and the LATD are kind of PD are part of ISDNs. ISDN was a really cool idea that never caught on really well. There are still some out there. What it really is a true digital phone circuit. What it allows you to do basically is have 128K, 264K lines, and then it's really confusing. The data channel is the control channel, a D channel, two B channels and one D channel. And you can send voice and data over the same line. Hey, you can do that with DSL, can't you? Hey, you can do that with cable, can't you? So lots of things have changed. It's an older standard, and what it's really good for is tests, because it's got so many different parts that you have to identify. Although I don't think that they're really asking questions about that anymore, because it really is a relatively old standard. This is the question that I asked earlier: where are the differences? Application. Is there any difference in a web server that's on a local area network and a web server that's on a wide area network? And he thinks the answer is no. Presentation, session, transport, network, and this is where we said there are not really any. Data link, frame relay, ATM, PPP, HDLC, that's where the differences are going to be. Serial, physical connections, serial versus Ethernet connections. So the differences are at layer 1 and layer 2. And he says here, many different types and prices, absolutely allows links to the internet or other offices. WAN links define a new type of layer 1 and layer 2 connectivity. So we've talked about both of them. We really, and you see Ethernet all the time, but the differences are down at layer 1 and layer 2 when we talk about WANs and LANs. 2 point-to-point release lines or point-to-point protocol. HDLC, the two protocols, and then we'll go through the other slides. But HDLC, Cisco proprietary. And if you have a Juniper, their HDLC is Juniper proprietary. HDLC protocols are all proprietary. There is no common standard for HDLC. Extremely low overhead, no features at all. When we talk about features, he says featurific for PPP. Features things like authentication, where you can have passwords on them. Moderate overhead, the industry standard. One of the questions on my very, very first CCNA test, I don't know, I focused it too much on that, was you came up to say you're trying to connect your Cisco router to a Juniper or whatever else.
So?
And you get port up, line protocol down. Fix it. If you do the show interface, you see that the encapsulation protocol is HDLC. That won't work with another manufacturer. That will only work Cisco to Cisco. And by the way, that's the default. So it all defaults to HDLC serial ports. If you want to connect to another manufacturer, you have to use PPP, and it's one of those really complex configuration commands. You go to the port and type encapsulation PPP. Have any of these commands been really all that complex? And if they were, you got the help screen a question mark. It's a matter of what do you use where, and that's where the help comes in too. Why is it so good so much? Because how often do you really configure a router, honest, except in a class?
Every day.
Every day? I'd say probably about every 2 years. We got routers that haven't been touched probably in 5 years. You going to remember all the commands?
No.
I'm not. Maybe you will. I'm not.
Why they create cheat sheets?
Cheat sheets? Yeah, but things change. Why don't you just use the help, the built-in help with the question mark when you go through these things? HDLC, bit-oriented data link layer, ISO standard protocol, specifies data encapsulation method. No authentication can be used, and this says it's a standard, and each of the manufacturers has their own standard when you do HDLC. Cisco HDLC, you got the flag, address, control, the proprietary part of the data frame. The data, the frame, check sequence, and flag. HDLC, flag, address, control, data, FCS, and flag. And if you had somebody else's, they would have a proprietary field in there also. There really is no standard. Point-to-point, transport layer, 3 packets across the data link layer, point-to-point link. This thing uses a handshake in order to get started. And it has features, link control protocol, things like it checks to be sure the link is up, it checks to see if you have authentication, and then it establishes the connectivity at layer 3. Can be used over asynchronous, dial-up, or synchronous. And if you're using, and I think probably nobody around here is anymore, dial-up, in the dial-up days, the protocol was always PPP, point-to-point protocol. The layer 2 protocol, the standard. And back to these other routers, if you're going to connect to Cisco to anything else, you've got to change the encapsulation to PPP, point-to-point protocol. Builds and LCP builds and maintains the link connections. And the link connections here are going to be at layer what? Since this is a layer, what protocol? The transport layer here is the SYNAC and the active 3-way to get the actual, yes, we're talking. But the link that we're building is at layer 2. This is a layer 2 encapsulation protocol. All this stuff layer 1 and layer 2. The OSI layer, the upper layer protocols, IP, IPX, AppleTalk, and the only one that we're really going to be concerned about is, of course, IP. Because IPX, anybody seen an IPX network lately? Me too. Anybody ever seen an AppleTalk network?
Maybe. I don't know. Yeah.
Really?
About 10 years ago.
And that's about how long ago I saw an IPX network. Maybe longer. IP is the standard. IP became the standard of the internet, so it's the standard for everybody else. One of the things that can be, I digress, handy about an IPX, if you translate IPX to IP, pretty darn good security. Because you really kind of talk about NAT between IP, IPX, you got IPX on one side and IP on the other. That'd be some pretty good security, wouldn't it? Kind of interesting. The layer 2 network control protocol, NCP, specific to each network layer protocol. So we have a network control protocol for IP, IPX, and AppleTalk. And again, since IP is the only one we're going to use, I'm going to have NCP for IP. Link control protocol, LCP, is the layer 2 configuration. It builds the layer 2 configuration. LCP builds its connectivity before NCP takes place, network control protocol. And this just goes through, is it there? Oh, yeah, let's connect. Is there authentication? This is the authentication. We'll go through the authentication process. HDLC, again, the Cisco proprietary. The physical layer, EITIA 232, V.24, V.35 ISDN. The V.24, V.35 are all standards you can look up. They're kind of like modem. V.25, I guess, was the 64K modem, something like, or 64K, yeah. So each of these standards are available depending on what we're using at layer 1. So WAN, LAN, we're talking layer 1, layer 2. Still. 232 is an international standard for serial communications. HDLC is a serial link datagram encapsulation method. LCP used in point-to-point connections established, maintained, and terminating when we're ready to do an orderly shutdown. Network control protocol establishes and configure the network layer communications. And you can have LCP working and not NCP working when you start troubleshooting these things. Simultaneous use of multiple network layer protocols. That at one time was a big deal, not necessarily a big deal anymore because we're really only using one network layer protocol. The authentication methods, authentication PAP and CHAP, the LCP configurations, PAP and CHAP. PAP, password authentication protocol, everything's clear text. CHAP, challenge handshake authentication protocol, the usernames are in clear text, and the passwords are actually a hash. When I say a hash, does that mean anything other than something that you may have smoked at one time? What a hash is a fixed length, and there's really only two hashing protocols. And MD5 is the one that's used primarily. It's a longer length number of gibberish. What it does is essentially turns the thing into gibberish. It is a one-way process. It can't be undone. When we do encryption, we decrypt. When we do hashing, there's no dehashing, unhashing, whatever it would be. What happens is the password has to be stored at the other location. Kerberos uses hashes. Most password authentication uses hashes. You know your password. You type your password in. The MD5 hashing protocol creates a string of gibberish and sends that string of gibberish to the other end. The other end uses the stored password, the password that's stored on it, the same hashing protocol, and creates the string of gibberish and compares the two gibberish strings. And if they're the same, you just got authenticated, and if they're not the same, you're not authenticated. So encryption, decryption, encryption and decryption is a two-way process. Hashing, CHAP, is a one-way process. It sends the usernames in clear text and CHAP, but it hashes the passwords. Compression can be used here. Error detection, quality, and magic numbers is a Cisco thing, that the magic number here for error detection. And multi-link, one of the things that it does use is multi-link. What multi-link does is allows us to, much like Ether channel, put two connecting lines together, two serial lines together, two phone lines together, and they act as a single line. So if you had multi-link in a 64K modem, we'll go way back. Two 64K modems acting in multi-link, they would act like a 128K modem. It has to be configured on both ends, but multi-link allows you to bundle connections together, much like Ether channel does in Ethernet. Multi-link, we're talking serial connections. Ether channel, we're talking Ethernet or fast Ethernet or gigabit Ethernet. PPP establishment, the link is these are the phases that it goes through. The link establishment, do we have connectivity? Authentication, if there is authentication, and that you're not necessarily going to have this phase. If there's no authentication, it just continues on to the network layer protocol phase, where it matches up if we have multiples, it would match up the IP to IP, IPX to IPX, AppleTalk to AppleTalk. Establishment phase, dial-up or the circuit switch network, the link establishment. Authentication, again, is optional in the network layer protocol. And all this goes through our magic cloud. Why they call it a cloud? Because I'm sure that, I think because nobody really knows what goes on in there. It's a big switching network. It's a huge telephone switching network. And we'll look at a little bit when we do frame relay. I'll show you what my cloud looks like when we do the demo, why these things work. The authentication, I think I already covered this. Password authentication, passwords are clear text, remote node returns the username and the password. Challenge is done at the start and periodically. That's what the challenge is about. Actually, the challenge is about sending a challenge. And you use the challenge to do part of the encryption. You use it as kind of a third party. Use the password, the hashing algorithm, and assault. There's something else that's there to create this hash and send it, and it uses the same thing on the other end. Challenge and reply sends a one-way hash, and it uses the MD5 hashing protocol. This is, and we'll look at this briefly and then we'll move on. Configure PPP on router A, config T, interface 00, the complex encapsulation PPP, Control Z, exit, however you do to get out. Control Z will bring you back to the enable mode. Find the username and password, router A, username, router B. On router A, the username is the other router, and it's whatever name that router has. If that router has the name Paris, that's the username. If that router has the name Jose Jimenez, you guys don't remember Jose Jimenez, do you? He was a long time ago. He was a comedian in the 60s. Anyway, if that's the name of it, that's the username. The password, Cisco, the password has to be the same on both routers.
So if the name is...
If I use name Dustin, username Dustin, password Cisco, then where we have router B here, that router would have to be named Dustin. Host name Dustin. Now that I answered your question before you ask your question. Go ahead. Sorry. Now I got him confused.
No, I don't know what I was going to ask you.
Uh-oh.
I blame you.
That's okay. You can blame me.
Blame him.
You can blame him, anybody. And on the other one, username router A, password Cisco. The passwords have to be the same. Username maps to the remote router, passwords have to match. Chapter PAP interface serial 0, the interface that connects these things together, so the passwords, the authentication is on the interfaces themselves. PPP authentication CHAP or PPP authentication PAP. And this one is, they're going to use both of them, Control Z. Control Z again sends you back to the enable mode. Password Cisco, say username pod1r2, pod1r2, password Cisco interface 00, IP address, encapsulation PPP, PPP authentication CHAP, and PPP is in front of it because that's the protocol. Remember, we can use more than, actually we can't use more than one. The protocol that we're using this encapsulation for, and this is just the same thing with the other router as the username. Number of examples there. Frame relay, high performance wide area network encapsulation method. It's an OSI physical and data link layer originally designated for use in ISDN. So it was originally designed for ISDN. ISDN really didn't catch on. But now we use it for serial connections. And frame relay is, again, a layer 1 and a layer 2 protocol. So we talked about the HDLC and the PPP are really for dedicated lines, one point to the other. One of the things that frame relay will allow, and we'll look at some pictures here in a few minutes, you can create a full mesh with it as long as you buy enough connections. You don't have to have the physical connections from one to the other, the way these things work. They use frame switches, and those frame switches, we're going to use a thing called DELC, Data Link Connection Identifier. It doesn't have, frame relay doesn't have MAC addresses. If you want to think about the DELC as the MAC address, that works fine, but there are no physical addresses in the serial world. The DELC is the way that we keep track of things. When we get to the picture, the DELC is kind of like going to the airport, which gate you go to. See, now we do that, and boy, we get there to see how that goes. So the OSI physical is originally designed, supported protocols, IP, DECnet, AppleTalk, Xerox, XNS, Novell, IPX, Banyan Vise, transparent bridging, and ISO. So a number of protocols. Yeah, I know we haven't ever talked about most of those. Banyan Vines was kind of neat. I don't know if anybody uses it anymore, but it was kind of a wireless. And when we were at Syncline Fleet, the guy said, "Oh, I love this because all I have to do is plug it in and it finds itself and it puts itself in the network." No real effort there. The protocol that won out in the end was IP, because that's what the internet runs on, and that's where we're going. It wasn't that very long ago that all of these protocols really were available. And as you look at the Cisco routers, as the new ones come along, some of these protocols are coming off. The new ones don't have IPX. That's the only one I really look for. Don't have IPX on them anymore. So protocols, yes, when it says that they can be done, the standard supports it, but the physical device itself may not support it. This is the big idea behind frame relay, and the big idea behind frame relay is that we can take this packet switch network, this cloud, and make the connections from each of these routers appear as lease lines, as direct connections. What we're going to use at the end of these things is a thing called a DELC, Data Link Connection Identifier. It's a 3-digit number that we tell stuff coming from our router to go to this DELC. When we get into it, let's see if I can find the one that I want, and then we'll go back. The one that I want, DELC 102 maybe, and DELC, and this one over here would have 3 DELCs. It might have 201, 202, and 203. You can have multiples. What you do, it's kind of like going to the airport. If you're going to go to New York, when you go to the airport, you look up on the big screen, the little TV, and it says go to gate 3. And that's essentially what the router does. Here on the serial 00, we would have sub-interfaces. And the sub-interface would say if we want to go to Missouri, you go to whatever that DELC is. Once you get on that DELC, these things are connected across the cloud using frame switches so that they go in a direct path called permanent virtual circuits. If what?
Through the cloud.
Through the cloud.
Through the cloud.
Same thing, if we want to go to Texas, then we would go to the DELC that connects to the Texas. So what we do, and when we do the configuration, we tell the system in the command the remote IP address, just like if you're going to New York, your destination, and then the local gate or the local DELC that you go to. Very similar to, I think, the way that those things work. Let's see if you, where were we? Anybody have any idea? Let's do before frame relay. Actually, that's about where we were, isn't it? Yeah, lease lines, and then before frame relay, here we go. Before frame relay, we actually would have to buy a dedicated lease line from one location to the other location. What frame relay allows us to do is to connect into the cloud. The ISP is then responsible for creating all this direct connectivity through the frame switches in his cloud. Frame relay, statistically multiplexing multiple logical circuits over a single physical connection. Wow, that's a fancy name for sub-interfaces, isn't it? When we do the sub-interfaces, we associate that interface with a Del-C, and then just like going to the gate at the airport, it then goes to a specific location, just like the airplane we hope goes to a specific location. Communications interface between the DTE and the DCE. Connection-oriented data link via virtual circuits, a complete path from the source to the destination before sending the first frame. So it's going to create the path before the first frame is sent. And that kind of makes sense, doesn't it? There are some things on the fly intelligent switching that we can use with some of these things. Tell you what, before we get into this, you want to take a break? This is getting a little longer than with the survey that you had to do, getting a little long. So let's take a break for a few minutes. So frame relay is an interface between the DTE, DCE, communications interface between the DTE, DCE equipment. Connection-oriented. What does connection-oriented mean? Oh, let's go way back. Connection-oriented means it's not connectionless, right? We said earlier on that the layer 4, you use the layer 4 protocol to establish the connection. So connection-oriented means that it establishes the connection before it starts sending the data. And we said that in a slide earlier than this too, I think. So connection-oriented data link communications uses virtual circuits, provides a complete path from source to destination. And when we went forward with those slides, that's what the dotted line represents, through however many frame switches that there are. The Del-Cs that we talked about, have talked about, will use are only locally significant. So the frame actually traverses this, the CSU, DSU, the DMARC, the central office, the DMARC, CSU, DSU. The permanent virtual circuit, the PVC, only sees a connection from one end to the other. And that's what we're going to see, is a connection from one end to the other, from one IP address to another IP address. And then the user sees the connection to the server. The routers only see the connections. Specify on the serial interface, and again we can do the other ones on the serial interface are really tough. You go to the serial interface encapsulation or whatever. A little bit more to set this one up. It has a little bit more, a few more configurations that can go. Encapsulation types, Cisco is the default encapsulation. There's a real shocker, right? Cisco's and other, this is not one that you've got to change to IETF. Between Cisco and non-Cisco, you can actually have the Cisco encapsulation on other devices. But IETF is the industry standard that if you're not going to use the automatic part with the Cisco encapsulation, you'll have to specify that one. So in this thing, interface 00 encapsulation frame relay question mark, and you'll have a RFC 1490 encapsulation IETF. You've now defined the encapsulation, and when we do these things, even when we use sub-interfaces, before you can create the sub-interfaces, you'll have to specify the encapsulation as frame relay on the interface, not on the sub-interface. So once you specify the encapsulation as frame relay, it's the encapsulation protocol for that interface and all the sub-interfaces that you create on it. Frame relay PVCs are identified by Del-Cs. I've alluded to that. All Del-C is a number that is locally significant. It's just like at the airport. If you go up there and you're going to New York, and over here at Roanoke says go to gate 3, if you go to the Greensboro Airport and you're going to New York, you may go to gate 67. So Del-Cs, just like the gate numbers at the airport, are only locally significant. And once you get to that Del-C or you get to that gate, you then go to your destination because of the way the cloud works. The ISP is responsible for what's in the cloud to create those virtual circuits. So what we have to know to do is to do the encapsulation, and to send it to that particular Delcy, that particular gate. Well, that was interesting, wasn't it? That was Jody. IP end devices are mapped to the Delcy's. Global significance are advertised to all remote sites as the same permanent virtual circuit. Local significance, Delcy's don't have to be unique. The only thing it has to be unique, if we have 3 Delcy's on a single interface, they all have to be a different number. But we could have Delcy 301 goes to Delcy 301. It doesn't matter. Just like if you got to New York, could you get off on gate 3?
Yeah.
Sure. But it's only significant at New York. But you couldn't have 2 gate 3s. You could have a gate 3A, a 3B, and a 3C. I understand that. But you couldn't have 2 gate 3s at the Roanoke Airport, or you don't have 2 gate 3s. Just like you couldn't have, and on the one, the hub that we'll talk about, it's got the 3 connections. They couldn't all be the same Delcy number because it has to go to a unique Delcy. So router A goes to Delcy, data link, and well, I've always heard it called Delcy. Data link connection identifier 100 goes through the cloud and comes out on Delcy 200, which is then connected to router B. And this is the picture that we looked at earlier. Delcy's are locally significant. It doesn't have numbers over here. We could have 100, 102, that's a 3-digit number. Doesn't matter what it is. It's only locally significant. One of the things, recommendation, when you go over here, and if we have sub-interfaces, you relate the sub-interface number to the Delcy number. It's just one of those things that makes it easier. And even if you're in a situation like in Missouri, Texas, and California that you don't need sub-interfaces, you may want to do it anyway, because what if all of a sudden now Missouri says, hey, we need to be directly connected to Texas, and they add another Delcy in here. Now you got to go back and configure the sub-interfaces so that they go to those locations because they'd be on different IPs to get from one to the other. So Delcy's are locally significant when we do these things. I had a thought and I forgot the thought, but sub-interfaces, locally significant because that's what that interface, sub-interface, sends its information. It's kind of like if you did a static route, an IP route, and you use the interface that it goes out of instead of the IP address of the next hop. It's got to go out that Delcy because that's the one that relates to it. Configuration, let me go back to this one quickly. There are 2 types, I talked about 2 types of, now we got 2 of them, 2 types of connections, multi-point and point-to-point. You'll notice this is a multi-point. And when we do the encapsulation and we do the sub-interface, the IP address will specify either a point-to-point or a multi-point connectivity. Multi-point, you'll notice that each of these, 192.168.1, are on the same subnet. The real difference between a multi-point and a point-to-point is in a multi-point, they're all on the same subnet. But if they're all on the same subnet, let's think way back to when we talked about routing and route updates in RIP. What happens if I send a RIP update into this interface and I don't make any changes? Is it going to be able to send it to these other locations? Split horizon prevents that, doesn't it? You can't send an update out the interface that it came in on, because even if we have sub-interfaces, it's still the same interface. It's the same network. You have to go in and on that interface, use the command no split horizon. You have to turn it off. Okay? So split horizon can be an issue with the multi-point. And again, we specify that at the startup. Your choice, the ISP doesn't care. Because what you're leasing from him are virtual circuits in the cloud. What you do at the other end of the cloud's up to you. All they're worried about is direct connectivity, and that's what the dotted lines show. From Missouri, we would have and don't have the Delcy numbers here, we would go to Delcy 100, to Delcy 200. What I do, and this is just me, if I did like Delcy 102 here, I put Delcy 201 at the other end. 103, 301, 104, 401 to kind of just help me know what goes where. So we're going to connect to those things directly. All routers on the same subnet, multiple Delcy numbers mapped to the interface at Arizona at the hub here causes problems with split horizon. We talked about that. And it causes troubles with split horizon. Can you overcome that? Yes. No split horizon on the interface. Interface configuration, point-to-point design. You notice that in the cloud it looks the same way, except this time we have Delcy numbers here. In the cloud it looks the same. But each of these locations are on different subnets. The hub here has sub-interfaces that relate to each of the other subnets. So serial 00.100, and again, use the sub-interface number. Guy that did these also recommends use a sub-interface number that's the same as the Delcy number. So serial 0.100 would go to Delcy 100, 192.168.1.1. At the other end is 192.168.1.2. And then we got the 2.1, the 2.2, the 3.1, and the 3.2. So each of these in a point-to-point configuration are on different subnets. The difference is you need more IP addresses. So that's the real difference between the multi-point and the point-to-point. The LMI, the local management interface, the purpose, keep alive multicasting. What this thing does, and if you use it in troubleshooting, show frame relay LMI, it'll tell you how many messages and how many errors and those kinds of things. And if you see that you're not getting traffic back and forth and your errors are building up, then you may want to look at what's going on with the system. Keep alive says multicasting, multicast addressing, and status of the virtual circuits. When we do the Delcy's, the frame relay configuration, one of the things that you probably will want to put at the end of the command is broadcast. What that allows is broadcasts. And why would we need broadcast? Like RIP. It enables broadcast and multicast. So unless you do that, RIP, OSPF, and the IGRP won't work across your cloud and it won't share routes that way. So you need to specify broadcast. This thing is called NBMA, non-broadcast multi-access, unless you turn broadcast on. Unless you turn broadcast on, we're not going to have multicasting or broadcasting. It turns both of them off. And the broadcast command turns both broadcast and multicast back on. LMI types, Cisco ANSI Q33, beginning of the iOS 11.2, the LMI type is auto sense, and that's really handy. You don't have to specify it. Automatically sensed. The default Cisco, and it'll auto sense whatever is available. Virtual circuit status are active, inactive, and deleted. Active is good. We're configured at both ends. An inactive means that you're configured, the other end's not. Deleted means that you put in a Delcy that doesn't exist, and when it gets to the ISP, oh, don't understand that one. It'll show up as a deleted circuit. And you can try those out. And one of the things I did notice in Packet Tracer, even if the other end is not configured, it shows it as active. If you go in and put in something when you do the configure, just make up an IP address and a Delcy number, it will give you the deleted when you show the frame relay LMI, whether it's effective or not. Sub-interfaces, multiple virtual circuits. I don't think we need to go through this because we've already configured sub-interfaces. We've done sub-interfaces. It's really tough, right? INTS 0/0.100, whatever we want the number to be. Those become the connection points, the virtual circuits, the virtual endpoints. The advantage of that is if you do a no shut on the physical interface, if we bring it up, it should bring all the sub interfaces up along with it. IP routing on one sub interface, IPX routing on another one, all the different advantages. One subnet on the one and one subnet on the other one. All sorts of advantages to that. Meshed and partially meshed networks, one of the things that we can do with frame relay without actually having to go out and buy dedicated connections, although you kind of do. You buy virtual circuits through the cloud. You can create a mesh or create a partial mesh or create a hub and spoke. Hub and spoke, this is the thought that I had a while ago. Hub and spoke is starting to have some issues because everybody's using voice over, not everybody, but a lot of people are using voice over IP. If you use a hub and spoke, if you have like maybe Seattle and Sacramento and San Diego and your hub's New York, we'll make them as big as possible and stay in the CONUS, then you're going to have some delay in your telephone conversations because everything goes from Seattle to New York and then back to Sacramento. You get some delay. You can get delay in hub and spoke. Data doesn't really matter. Data doesn't care. Voice does. Yes?
Well, even when you connect to certain websites, like when you go to Yahoo, it connects, sometimes it connects to Dallas.
Yep.
And then
Yep.
it connects to some
Exactly. You don't always know exactly where it's going to be. But delay can be an issue with the hub and spoke arrangement when you get to voice. Data doesn't really care if it's a delay, does it? I mean, we care if it's a delay on the web pages, sure. We see a little bit of that. But voice does care about delay. So the encapsulation, creating sub-interfaces, INT, encapsulation, frame relay. INT S0, whatever we want, .16, treat as a multi-point link. You either, again, specifies a multi-point or a point-to-point, depending on how we decide whether we want them to all be on the same subnet or whether we want to be on different subnets when we configure these things. And we have to, one of the way inverse ARP, two methods. Okay, one of the ways that, anyway, to get the DELCI's two methods, frame relay map command, and we'll go through that when we do that. Inverse ARP function where it automatically finds the DELCI's. Each of those can be used. The map command, encapsulation frame relay interface, that's 0.16 point-to-point. No inverse ARP, IP address, frame relay map IP, and the map IP is the remote IP address, map New York, where we're going to the DELCI number, and the second number here is the DELCI, just the DELCI number, not preceded by the characters DELCI. IETF, we specified the type protocol, and then broadcast. You want the broadcast, again, command at the end so that your dynamic routing protocols will work. Not necessarily the other broadcast, but so that the switches can broadcast the dynamic and multicast the dynamic routing protocols. This turns off on both broadcast and multicast. And then config frame relay map IP 172.30.18, DELCI 17, broadcast frame relay to 18. So this one is one that has going to 3 different locations, 3 different DELCI's going out of it. Inverse ARP, encapsulation of the IP address, point-to-point encapsulation frame relay, IETF, and the IP address that goes with it. A couple of things that happen here. They talk about discard eligibility. When you buy a frame relay, you buy a committed information rate, which is the guaranteed rate, and then you get a burst rate, which is in excess of what you're paying for. So you can actually, this is one where you actually can get more than you're paying for. Just like cable, you can get more than you're paying for. Anybody ever look at cable, I'm buying 5 and I get like 10 or 15 or 20 down? Occasionally. I'm getting more than I'm paying for. You can get more than you're paying for with frame relay. That's one of the things that it's, one of the reasons it's popular. What it really is, and think about it, is a big basket of bandwidth. And you buy a little bit, and somebody else buys a little bit, and somebody else buys a little bit. is everybody going to be using the maximum bandwidth at the same time? And what this says is no, that's not going to happen. So that you can actually go above that. Discard eligibility means that any bandwidth above your committed information rate, above what you bought, is eligible for discard if the network gets too busy. FECN, forward explicit congestion notification, and backward explicit congestion notification. As the packet goes through the cloud, through the frame switches, if it detects congestion, if one of the switches detects congestion, and we're in the cloud, the forward explicit configuration notification bit will be changed from a 0 to a 1, saying there is congestion. When it gets to the other end, the router that's going to answer marks with backward explicit, this is kind of confusing, the BECN for the reply traffic to tell the other end that there's congestion to slow down. So the FECN is marked in the cloud. The BECN is marked to tell the originating station to slow down, that there is congestion between the two. Committed information rate, cost savings, good for bursty traffic if you don't use 100% all of the time, not good for constant amount of data transmission. So what we said earlier, show frame relay, a number of things that you can do, and I think that as you go through these things and look at these things, take a look at these things for what's there, what you can see as you do the configurations, the LMIs and those things. Running configuration, encapsulation frame relay map 200. Why can't the router talk to router B? We'd have to look and see, maybe configured on one end but not on the other end. Router RIP, if we didn't have the broadcast, router RIP would not go across the frame cloud. Okay, VPNs, again, briefly VPNs, virtual private networks, or virtually private network. What's a real private network? A real private network. If this isn't a virtual private network, what's a real private network?
Something that's not virtual.
Something that's not virtual, what would that be? How about a dedicated serial connection? Would that be a private network? Private connection. What a virtual private network does, and again we show these really cool little pipes go from one point to the other. It's got to go through the router. What we do is encrypt the data that goes from point A to point B. It's encrypted at one endpoint, a VPN point, a source and a destination VPN endpoints. It gets encrypted on the one. Has to have an unencrypted IP address, remember, because if you encrypt the IP address, the router won't be able to read it. So it gets a new header on it, you encrypt the data, and depending on which way there are a couple of different ways to do it, but if you encrypt the maximum encryption, encrypts everything, including the private IP address or whatever IP address you're using, puts a new header on it, new header being a new IP address, sends it to the other endpoint where that header gets ripped off, it gets decrypted and sent to the back-end private network. So in a nutshell, that's what VPNs are. VPNs are just, we encrypt the data packets. Means it's going to take more resources. It's going to slow down your connectivity. Types of VPNs, remote access VPN, site-to-site, extranet. Remote access is if I connected from home to here, I would connect to the firewall or the whatever, and I'd have an encrypted connection from my computer. Remote access VPN. Site-to-site, router-to-router. A router in Roanoke is all the data going to Virginia Beach might be encrypted. And we do have one of those. The significant data, the Moodle traffic isn't because of access control lists that filters some of the traffic into the VPN. The stuff that comes from financial aid, for instance, when they communicate with the database, that's all encrypted. When you go to Moodle, that's not encrypted. So it goes into the encryption portion of the router, gets encrypted, and then gets sent to the remote location. Extranet VPNs, extranet is when you let somebody onto your private network. I think a big difference here is in the terms. The functionality is the same. It's encrypted data from point A to point B. So with that, I told you the VPNs would be really brief. What is a VPN? What does a VPN do? Questions? Going once, going twice.